These are some additional notes on ratios, rates, and specifically unit rates. So let's just review here. What is a ratio? A ratio is simply a comparison between two numbers. So if you look at the picture on the right-hand side, we can see that there are 5 girls and 15 boys. So a ratio would be comparing for every 5 girls, there are 15 boys, using this for every statement that we used way back when we were studying the comparing bits and pieces unit. Now a ratio can be written using the following symbols. We can write this ratio, 5 girls and 15 boys, as 5 girls over 15 boys as a fraction. And we can write it as 5 girls to 15 boys, or we can write it with a colon here, 5 girls and then the colon and 15 boys. Notice that we are always starting with the number of girls and then ending with the number of boys. Order is important here. Now, it's helpful to reduce the ratios to simpler terms sometimes. So when we do that, all we're asking you to do is to divide both the numerator, so we'll write this out, and please add this in your notes, and the denominator by the greatest common factor. So if we look at these two numbers in our ratio, 5 and 15, the factors for 5 are 1 and 5. Well, 5 is also a factor of 15, so the greatest common factor for both 5 and 15 is 5. We can divide both the numerator and the denominator by 5. And I can write an equivalent fraction in its simplest terms here as 5 divided by 5 is 1 over 15 divided by 5 is 3. So 1/3 would be this fraction reduced to its simplest term. And again, I can write this as a 1 to 3 or a 1 colon 3. So for every 1 girl, there are 3 boys. For every 1 girl, there are 3 boys. Again, for every 1 girl, there are 3 boys. For every 1 girl, there are 3 boys. For every 1 girl, there are 3 boys, and we did that 5 times. So what is the difference between a rate and a ratio? Well, a rate is just a ratio that uses 2 different units. So if you think about the example that we had in class the other day, we were looking at ice cream. In this case, our chocolate chip ice cream here costs $5 for 2 quarts of chocolate chip ice cream. Now the units here are just simply, it's going to be the price or the cost and the size here. So our units here are going to be in dollars. Oops, I'll get rid of that. And the size are quarts. So those are the 2 different units. So when you're writing a ratio as a rate, it's really important to label your units. So for example, I could write this as $5 to 2 quarts as a fraction. Or I could list the actual size first, 2 quarts for every $5. Now, equivalent rates can be written by scaling up or down. So we're going to slide up this picture here. We're going to use a table to help us make sense of this. So the cost for the ice cream is $5 for exactly 2 quarts. Now, we can scale this down by cutting this number in half. So when I cut something in half, I'm actually dividing it by 2. When I cut 2 in half or divide it by 2, I end up with 1. So I have to do the same thing up here with the cost, $5, and if I cut that in half or divide it by 2, I have $2.50. So an equivalent rate here is it's $2.50 per 1 quart of ice cream. This is an equivalent rate to saying $5 per 2 quarts of ice cream. And again, if I want to scale this down again, I could divide this again in half. Half of 1 is simply a half. So I could have 0.5 quarts. And then half of $2.50 would be $1.25. So I could write this rate as $1.25 per 0.5 or half of a quart. All of those are equivalent rates. Now I can also go the other direction here and I can scale up. So if I started here with my unit rate, that even makes it easier to scale up. So my unit rate here is $2.50 for 1 quart. If I want to scale this up to know what the cost of 3 quarts is going to be, I'm just multiplying by 3. So 3 times $2.50 would be $7.50. An equivalent ratio here is $7.50 per 3 quarts. Let's say I wanted to know what the cost would be for 10 quarts of ice cream. Again, I'm going to scale this up from the price for 1 quart and multiply that by 10. So I'm also going to have to multiply the price by 10. $2.50 times 10 is 25. So $25 for every 10 quarts of ice cream. So equivalent rates all have the same unit rate. So if I'm actually going to get a different color here, write that in here. My unit rates here are shown right here, where I've got $2.50 per 1 quart of ice cream, and you'll see that same $2.50 per 1 quart of ice cream that I used in both of these tables to scale up or down. So if I need to find a unit rate where one of these numbers is 1, I'll get the same unit rate no matter which of these equivalent rates that I start with. All right, so let's talk a little bit more about unit rates. We'll flip to the back side here. A unit rate is just a ratio that compares 2 different units in which one of them is a 1. So how do we figure out a unit rate? Well, we're going to write the ratio as a fraction, and then we're going to divide the numerator by the denominator to get a unit rate in which the unit in the denominator is a 1. So if we look at the picture that we have here to the right, we see the chocolate chip ice cream. The cost is $5 per 2 quarts. What is the price per quart? So now what I want to do is I want to think about the price as my numerator and the size, or the number of quarts, as my denominator. If I set this up, I know that I have $5. It costs $5 for 2 quarts. Now, if I want to find the price for 1 quart, I simply divide my numerator of 5 by 2. Remember, the fraction bar also means division. So 5 divided by 2 gives me an answer here of $2.50 per quart of ice cream. So because I wanted to find out the price per quart, I wanted the size to be my 1. So I had to put the size, or the number of quarts, in the denominator of my fraction here. So when I divided, it was cost divided by size. When the price per 1 unit, I calculate that, it is also called the unit price. So in this case, $2.50 is also the unit price because it's the price per 1 quart. Now I can also think about a unit rate by using the following question. What is the number of quarts that can be purchased for $1? So in this case, my unit here is going to be the price, not the size or the quarts. So now I'm going to set up my ratio with the size, or number of quarts, as my numerator over the price, because I want the price to be my unit of $1. When I set it up this way, I show 2 quarts as my numerator, and I'm comparing that to my price here, or the cost, $5, in the denominator. So now remember that fraction bar means division. I start with 2 and I divide it by 5. When I take 2 and I divide it by 5, if I set this up as long division, I can see that 5 doesn't go into 2, so I'm going to have to put a decimal here and add a 0 in the tens place. Now 5 goes into 20 4 times. 4 times 5 is actually 20 with 0 left over. So my answer here is 0.4 or 4/10. So this means that 4/10 of a quart costs $1. Now, a good consumer will compare the unit price of items to find the best deal. So let's look at the last example here to figure out which is the better deal. $4 for a 20-ounce box of Froot Loops or $3 for a 12-ounce box of Froot Loops. So when we talk about unit price, we're talking about the price per one unit. In this case, our units here are ounces, so we're looking for the price per 1 ounce. That means when I set up my ratio here, I'm going to use the cost in the numerator and the size, 20 ounces, in the denominator. Again, I'm going to treat this as division. 4 divided by 20. If you do the long division here, let's do that. 4 divided by 20. 20 can't go into 4, so I have to add a decimal and a 0 in the tens place. 20 goes into 40 2 times. Whoops, 2 times 20 is 40 with 0 left over. So my answer here is 0.2 or 2/10. And remember, this is my cost. So 2/10 is actually 2/10 of a dollar or 20 cents per 1 ounce. Now if I do the same thing for the other box of Froot Loops, I start with the cost of $3 over the size, which is 12 ounces. So I'm going to take 3 and divide it by the number of ounces, 12. And when I do that, 12 does not go into 3, so I have to add a decimal. 12 goes into 30 2 times. 2 times 12 is 24. There's 6 left over, so I have to carry down another 0. 12 goes into 60 5 times with 0 left over. So my answer here is 0.25 or 25 hundredths of a dollar or 25 cents per 1 ounce. So which is the better deal? Well, if I'm looking at the same amount of cereal, which I am, 1 ounce of cereal, you can see that the $4 box is actually the best deal. So the 20-ounce box for $4 is the better deal because 20 cents per ounce is cheaper than 25 cents per ounce.